Hello, back again. Today we're going to talk about complex fractions and operations with mixed numbers. At least that's what we're going to try to do. I'm sure that there's some of you, when I said complex fractions, just kind of shook your head because, you know, fractions are complex, so why do they need to have a special name? Well, just so that you understand, complex fractions in a mathematician's mind is just a fraction, or a complex fraction is a fraction that basically has baby fractions, or in other words, fractions within a fraction. For example, if I have 2/5 divided by 3/4. Now that is a little bit more complex, and maybe one of the problems is that you have these three fraction bars, so it makes it a little more difficult to look at and tell which one of those goes with which numbers. But I think if you look at this, and if it's written rightly, you can see there that this is 2/5 over 3/4. Well, complex is given, they're given the name complex because of what they have, not necessarily because they're complex. Because if you take this situation here and you read it properly, what it says is, I've got 2/5 divided by 3/4. Well, we already know how to divide fractions, and so if we look at it that way, then we know what to do. And maybe, just maybe, you might want to write that a different way. So that you can see it that way. Because then you're supposed to know, hope you do know, that we don't divide by fractions. Rather, we multiply by the inverse. And remember, we're actually operating on this fraction, so changes we make are in this fraction. So rather than dividing 2/5 by 3/4, we're going to multiply 2/5 times 4/3. Make sure you remember something. We don't reduce or simplify when we're dividing fractions. The only time we do that is when we're multiplying fractions. So once we take this division problem and turn it into a multiplication problem, then we do have to check, as quick as it's a multiplication problem, we have to check to see if there's anything we can do to reduce it. Well, there are no factors of 2 anywhere in the denominator. There are no factors of 5 in the numerator. No factors of 4 anywhere in the denominator. No factors of 3 in the numerator. So we're done. There's nothing else we can do to reduce. So after we've done what we can with reducing, then the next thing we do, numerator times the numerator equals the numerator. So 4 times 2 is 8. Denominator times the denominator equals the denominator. And just remember, when we're multiplying, we don't have to have the same kind of denominator. We only have to worry about sums and addition and subtraction, because to get a total, you got to have a total of the same thing. So that's all you need to remember about this. If I have a problem like this, 10 1/3 over 3 3/5, that qualifies as a complex fraction because it has fractions within the fraction. But if we look at what's actually there, that is 10 1/3 divided by 3 3/5. And so we then will deal with that, and we haven't talked yet about that, so I'm going to review that in just a minute, and then we'll look at problems like that. But that does qualify as a complex fraction, and that's what I wanted to make sure you were aware of. So we will then, knowing that this is what we're going on, then we'll just go ahead now and operations with mixed numbers. Mixed numbers, remember, are called mixed numbers because we've got whole numbers and fractions mixed together. This is a mixed number, and this is a mixed number. So we want to know what we should do with that. If I have a problem like this, and we'll leave that one up there because we're going to talk about it in a minute, but if I have something like this, 2 3/4 times 3 1/5, there's several things you can do with this, but let's see if we can find the thing that's the easiest. We might as well learn how to do math the easy way. One thing that you need to understand, and if I say this and you think about it, you can hear it. When I say 2 3/4, that means I'm going to 2, and then I'm going 3/4 beyond that. If you were thinking about that on the number line, it would look like this. 2 plus 3/4, and then that would be multiplied by 3 plus 1/5. Well, we know how to do this. I mean, we could actually do this, but it's going to be a lot of work because we'd have to multiply the 2 times the 3, then the 2 times the 1/5. This is kind of like a double distributive property. Then I'd have to go 3/4 times the 3, and then 3/4 times the 1/5. I don't know about you, but just thinking about all of that and then simplifying after we get done, that sounds like a whole lot of work. And because of that, it's just common practice that instead of trying to do something like that, we take mixed numbers when we're multiplying and we change them to improper fractions. So this one, remember I'm dealing with fourths. I have 2 full groups, that's 8, plus those 3 gives me 11/4 times 3 1/5. Dealing with fifths, I got 3 full groups. That's 15 plus this one here gives me 16/5. And now I have a problem involving multiplication of fractions. So I don't have to worry about it. So whenever we're talking about multiplying and we got mixed numbers, rather than doing that, we change to improper fractions. Why? Because it's easier. Why not do it the easy way? Okay, so then once we've decided, and remember we're down here, once we've decided that it's a multiplication with fraction problem, then what's the first thing we do? Okay, always reduce if we can. So we go here, 11, no factors of 11 down there, 4. There is a factor of 4 up here in the numerator, so we divide a 4 out of each one of these. Look at the 4, no factors of 4, and 5's of prime. So at this point in time, we've reduced all that we can. So then we remember, numerator times the numerator, 11 times 4 is 44, and 1 times 5 is 5. Now, if you feel like you ought to make it a mixed number because that's what we started with, then go ahead, you can do that. Remember, I'm dealing with fifths. Fifths means it takes 5 to make a 1, to make a whole, because that's what fifths are. So I find out how many groups of 5 there are in 44. I do that by dividing. 5 will go into 44 8 times. 8 full groups of 5 is 40. And then I've got 4 left over, and so my answer is 8 4/5. So, and either one of these answers will be acceptable. Remember, with fractions, the only time we have to do it a certain way is if it's in a situation where it makes more sense to say it as a mixed number than an improper fraction. So, whenever we're multiplying fractions, or mixed numbers, we change them to improper fractions. Well, that leads us right in to division of mixed numbers. So let's see what happens when we do that. So let's say we have a problem like this. We've got 1 3/5 divided by 2 4/5. There's really only one thing that we need to remember. Division is multiplication. We just multiply by the inverse. So if we remember that, then all we really have to remember is when I'm dividing with mixed numbers, I'm really multiplying with mixed numbers. And whenever we have mixed numbers and we're multiplying, what do? Change them to improper fractions. So that's what we're going to do. I have one full group, that's 5 plus those 3 gives me 8/5. Divided by, here 5 again, I got 2 full groups, that's 10 plus those 4 is 14/5. So now I've got this problem, and it's a problem of dividing with fractions. So then I got to remember that. We don't divide with fractions, rather we multiply by the inverse. Again, we multiply by the inverse of the second one, so it's 8/5 times 5/14. Okay, now that it's a multiplication of fraction problem, then the first thing we do, if we're smart, is we reduce. So I look here at the 8, look down here, and sure enough, there's a factor that's the same in 8 and 14. It's just a 2, but it's a 2. So I divided 2 out of each one of those. Then this is an easy one. Those kind we like because it's easy to tell. There's a factor of 5 in each one of those. And so now when we multiply our numerators together, we get 4. We multiply our denominators together, we get 7. So, much simpler this way, and that's why we do it. We change from mixed numbers to improper fractions for multiplication and division because it's a whole lot simpler to do that. So, just practicing with that, let's just quick do one more practice problem with it so you can see. If I have 12 and 5/7, and I'm dividing by 3 and 2/7. Okay, when I look at that, that's a complex fraction, and it's made up of mixed numbers. So when I'm dividing with mixed numbers, I always change them to improper fractions. So I've got 12 full groups of 7, that's 84, plus these 5, that's 89/7. And I'm dividing by, and I'm going to save a step and write it like this so I can see a little bit quicker. I'm dealing again with 7s. I have 3 full groups, that's 21, plus those 2 gives me 23/7. Now since it's division with fractions, we multiply by the inverse, so I'm going to have 89/7 times 7/23. Okay, 7, I can see those really easy. 89 is not, 23 won't go into 89. 23 is prime, so there are no other factors but the 23, so we've done everything we can. So now again, we multiply the numerator times the numerator, and you might want to remember to put a 1 there just so that you've got it to remember. So I'm going to have 89 times 1 over 1 times 23. Meaning my answer is going to be 89/23, or if you want to write it as a mixed number, you can. Don't have to. This one will be a little bit messy, but it'll go in there 6 times, or excuse me, 3 times. 3 times 23 is going to be 69. When I subtract that from 89, I'm going to have 20. So I have 3 and 20/23 of another group. So that's our answer for that. So that takes care of multiplication and division. Now let's just talk about addition and subtraction. Everybody seems to learn when they're dealing with mixed numbers, the first thing they want to do is change them to improper fractions, and actually we just did it there, and so it's kind of accepted. But I want to show you something that will show you, I hope, that it's a little bit easier. So if I have, let's see, 3 2/3 plus, let me get the numbers here, 2 1/5. Whenever we're asked to add numbers, don't we automatically just line them up? We do that to make sure we're adding things that are alike. Why don't we just go ahead and do the same thing here? I mean, it's not going to be like you're going to have to learn something new. This is what you do all of the time. So line them up. When we add, we always go over to the right and start. And the reason for that is because sometimes when we do something over here on the right, it impacts things as we go across. So we're going to go to the right here. And look what we find. We've got 2 fractions. So let's just go ahead and deal with that. We know how to add fractions. First of all, we look at this. We don't have a common denominator. We have to have a common denominator. Well, since 3 and 5 are both prime, this common denominator we're going to need is going to have a factor of 5 and 3. So that's 15. Or if you think about what's the smallest number that the 5 and the 3 will both divide into, that's also 15. We have to change our fractions here so that they have a denominator of 15. Well, you look at this. You have to multiply the 3 by 5 to get 15. But you got to multiply the numerator by the same thing. So there's 10/15. Here, you have to multiply the denominator by 3. So you have to multiply the numerator by 3. So that gives you 3/15. Okay, now those are replaced by our new fractions that have the same denominator. And since they do have the same denominator, we can add them. Our denominator is going to be that 15. And our numerator is going to be, we've got 10 here and 3 here. That's 13. Okay, we aren't required to do anything with that, so we just move over to the next column. And we're adding 3 plus 2 is 5. Now, if I do it the other way, and you can do it the other way. The problem is that you just get bigger numbers to work with. You still, well, let's just look at it. I'm going to have 3 2/3, that's 9 11/3, plus 10 11/5. I'm still going to have that common denominator. It's still going to be 15. I'm still going to have to multiply the numerator and denominator of this one by 3. So that gives me 33. Multiply the numerator and denominator of that one by 5 to make the 15. That gives me 55. Now I can add those together. And when I do, I get 88/15. Okay, that's all right. Those numbers are a little bigger, and sometimes people get a little nervous when they're dealing with bigger numbers and they make mistakes. You always have to remember, you have to reduce it if you can. And when you look at this, it may be a little bit harder to tell that. So that may be another reason for doing this, but this is okay. If you do want to do it this way, let me just suggest that you change this to an improper fraction, because then the numbers you have left will be a little bit easier to deal with, and you can tell whether you need to reduce. 15 will go into 88 5 times. 5 times 15 is 75. Okay, we used up 75 of those. That means we've got 13 of them left, and they're 13/15. So we get the same number, but we just have smaller numbers to work with. So if you like working with small numbers, you've already learned how to do this, so you don't have to do anything different. So it's an option. Let me just suggest that it's an option, and there are some reasons for doing it. But if this is what you're comfortable with, do what you're comfortable with. As long as you know how to do it and you're comfortable with it, do that. Okay, let's just talk about subtraction. And it's not going to be anything different. Let's say we've got 7 3/8, and we're going to subtract 3 5/7. Okay, if you do it the way I showed first, then same thing. Now you got to remember, when we subtract, we're subtracting the whole thing. We're subtracting the 3. We're also subtracting the 5/7. So I'm going to come over here and I'm going to subtract those. But again, I have to have a common denominator. We need a factor of 7 and 8. So I'm going to have to multiply the numerator here by 7 over 7. The denominator here by 8 over 8. That's what it takes to get me that common denominator. It has to have a factor of 8 and 7 because 7 is a prime. So this is going to give me 21 over 56. This is going to give me 40 over 56. Now this does create something just a little bit different. Not different than what we've done. You know how to do this, so don't let yourself be talked into believing otherwise. When I look over here, you can't subtract the 40 or the 21 from the 40 from the 21. It's not big enough. But you've been down this road before. What do you always do when the number that you're subtracting from is too small? Okay, it's a way of life for us. If we don't have enough, we go borrow. So I'm going to go here and borrow one. Now, here's where you have to be careful. That one that I just borrowed, I have to look over here and make sure I know what I'm dealing with. When I have something like this, 731, and I'm subtracting 129, that one I borrowed there actually was a 10. So when I put the 10 with the 1, I get 11. 10 plus 1 is 11. But it's simply because I borrowed a 10. Now here, what I'm dealing with in this fraction is I'm dealing with 56s. And you've got to remember that. That 1 that I just borrowed is represented by 56 of those 56. So that's what I have to add. That's going to give me a 77 total. So I got 77 56. I'm subtracting 40 of them. That's going to leave me with 37 of them. And 6 subtract 3 is 3. Okay, if you need a little more work with this to understand, remember you can watch the video over again and get the notes out, because usually on the notes I've got some extra problems put on there for anybody who wants to actually practice a little bit more with them. So get the notes out and work with the problems that we didn't do here today so you can see how to do it. Hope that helps. Have a great day, and we'll see you next time.